Good morning viewers, welcome to Telepedia Tutorials. If you're writing down or work, I believe you will not regret subscribing to my channel. We have been on this topic electrolysis and we have talked about a lot on it. If you have not been following the video, you can go through my channel and start the video or the lecture from the beginning. It will go a long way to help you understand this level we are about to look into. So we are looking into aqueous electrolysis. This represents electrolysis of substances when they are dissolved in water. As I said earlier, for you to electrolyze a substance, you must convert it from solid state to liquid state. This makes the ions to be mobile. Ions of an ionic compound need to be mobile in order for that compound to undergo electrolysis. So this level we are now, we are electrolyzing a substance, an ionic substance dissolved in water. And in this question, we are to determine what will be discharged at the anode and cathode during the electrolysis of these given compounds. So we are starting with compound 1. That is where we are going to look into compound 1. Now, in the previous videos, we said that whenever we are treating electrolysis of aqueous compounds, preferential discharge of ions comes in. I'll have three factors that influence preferential discharge of ions: position of ions in electrochemical series, concentration of the ions, and nature of the electrode. These are the three factors, but the most important one is this number 1. Though number 2, number 3, we can look into it as we move forward, but the most important one is the one we are going to look into. Position of ions in electrochemical series comes down to knowing the electrochemical series. This is the electrochemical series. It lists out all the ions you are meant to know in chemistry, from the most reactive to the least reactive. So in this table, potassium ion is the most reactive, while gold ion is the least reactive. So during electrolysis, if two ions are competing, competing ions, you need to compare them in your electrochemical series. The one that is above is strong. It will not be discharged, that is, it will remain in the solution. The one that is below is weak. That means it's going to be discharged. It's going to move away from the solution. So that's the basic law with respect to electrochemical series. Strong ions remain in solution, weak ions are discharged. The same thing applies to electrochemical series of anions. As you can see, fluorine is the strongest, hydroxide ion is the weakest or the least in the series. So these ones, they are not usually gotten through aqueous electrolysis. They can be gotten through molten electrolysis, while these ones, they can be gotten through aqueous electrolysis. And anytime hydroxide ion will be discharged, it is discharged as oxygen gas, not hydroxide ion, oxygen gas. But chloride ions are discharged as chlorine gas, bromine gas, iodine gas, and so on and so forth. Now, coming back to solution 1, that is electrolysis of aqueous sodium sulfate. Okay, now looking at this is the electrochemical cell representation of it. So we have dissolved our sodium sulfate in water. When we pass electricity, this solution is going to decompose. So both the sodium sulfate and the water will undergo ionization. That is, they form positive and negative ions. Now the elements in the left will form positive ions. The elements in the right will form what? Negative ions. Please note, whenever water undergoes ionization, it's going to form hydrogen ion and hydroxide ion. Please note that, it's very important. Now, what is going to happen? We have two electrodes, the anode and the cathode. The anode is positive because it is connected to the positive terminal of the DC source, while the cathode is negative because it's connected to the negative terminal of the DC source. Now, Anything moving to the positive is going to lose electron. Anything moving to the negative is going to gain electron. Electron is negative. Electron is negative. So if something is positive, that means it is deficient of electron. If something is negative, that means it has a high efficiency for electron. Now, stating that fact, two cations are competing, sodium ion and hydrogen ion. Two anions are competing, sulfate ion and hydroxide ion. Following the principle of position of ions in the electrochemical series, we are now going to state which one is strong and which one is weak. One will look at our electrochemical series. We are going to say that sodium is stronger than hydrogen. So we label sodium strong and we label hydrogen weak. When we look at our anion electrochemical series, we are saying that sulfate is stronger than hydroxide, hence we label sulfate strong, we label hydroxide weak. Now we move forward. The weak ones will be discharged while the strong ones will remain in what? Solution. Now discharging. Hydrogen ion, which is weak, will migrate to the negative. Opposite ions attract each other. So hydrogen ion, which is weak, will migrate to the negative, which is cathode. Cathode attracts cations, anode attracts anions. And hydroxide ion, which is negative, will migrate to the positive electrode, which is the what? Anode. Anything moving to the negative electrode will gain electron. We say it has undergone reduction. Anything moving to the positive electrode will lose electron. We say it has undergone oxidation. Now we are going to write an equation to express gain of electron and loss of electron. So as I said, anything moving to the cathode is going to gain electron. So at the cathode, reduction occurs. At the anode, oxidation occurs. Now hydrogen ion is migrating to the cathode. You can look at this. Hydrogen ion is migrating to the cathode. That's all right. Cathodic half equation is concerned with hydrogen ion. When hydrogen ion migrates to the cathode, it will gain an electron to be converted to hydrogen gas. Please note that hydrogen ion migrates to the cathode, but hydrogen gas is discharged or hydrogen gas is produced. When we balance the equation, we have two hydrogen on the right, one hydrogen on the left. Balancing the equation, we are going to have two hydrogen ions. So if two hydrogen ions are to gain electrons, how many electrons will be gained? Two electrons. So during this electrolysis, two hydrogen ions gain two electrons to form hydrogen gas. And that represents the cathodic half equation for this electrolytic process. As we move to the anodic half equation, in the anodic half equation, as we said earlier, the hydroxide ion is migrating to the positive electrode, which is the anode, and the anode is going to undergo oxidation, which is loss of electron. Now, so this is hydroxide ion. It is losing electron to form OH. OH does not exist alone. It combines with other OH. When that combination occurs, they are going to split to form water and oxygen gas. Water and oxygen gas. Now, when we combine this I and II, how do we combine it? This is our starting, and this is our ending. So that's how we combine equations. This is our starting, we write it. This is our ending, we write it. So, based on the balancing we did here, we are saying that 4 hydroxide ion needs to lose 4 electrons to form water and oxygen gas. As I said in the previous video, whenever you are writing equations with respect to anodic half equation, your equation should be in positive. So when we take this minus 4 electron across, it becomes plus 4 what? Electrons. And this cathodic half equation and this anodic half equation, it simply expresses what is happening at the anode and cathode which also tells us what will be produced after the electrolysis. So by these equations, we can say that hydrogen gas will be discharged at the cathode. We can also say that oxygen gas will be discharged at the anode. So with this, we have solved the question of electrolysis of aqueous sodium sulfate, and in the next videos I'll be posting, we can look into other compounds that are necessary. So I believe you have gained something in this video. Until next time, subscribe to Telepedia Tutorials.